Alright, let's start. So I'm Meena. So today I will in charge of this section and then another section, and then Roland will come back at the end. So today I will talk about the very basic statistics. So yesterday, Wednesday and yesterday we are talking about how to start R, how we can play with the data and so on. So let's a little bit apply how we can get some statistics. So before we start, let's open the R. I just make a new R script. So here click Files and New Files and click R script. So I opened my new R script. And here in environment, we have several data sets we play with, but I want to just clean up. I just want to start a very new thing, like just start with a blank. So I will remove whole list of this. So if I click run, and then now you can see the whole environment is empty. So let's start with a blank, like just empty environment. Everyone is okay so far? So, okay, maybe here we can also use this sticky note. So if you have an issue, just please put the red sticker note, and then the TAs can help you. So before we start the statistics, I will play a little bit different things. So, I think the first day we are talk about the experiment design, how we can do the randomization, how we make how is the replicate is important, how we can make a design, block designing and so on. So I will start to use how we can randomize in R. So we have a function called sample. So now, see we have a, sample function, means randomly we can sampling from whole our, cohort. So for example, let's start a very easy case. So from 10 numbers, 1 to 10, I want to randomly select the 2 numbers. Okay, so sample, and then I can say, among the 10, number 10, I want to select 2. Okay, then I just run, and then I got 7 and 10, right? And probably you have a different number, right? So, and then I will just run again. Now, I also have all different numbers, right? However, if you want to set, always you want to select the same sample, actually we can start set seed and any number you want, right? Means they actually set some seed for randomization algorithm. Then whenever you run again and run again, actually you can get the same numbers. For example, I will select, let's see how I will select this 2 line and then run. Now we got the 7 and 3 and 7, right? If I just run this sample function only, I will get a different numbers, right? However, I will just select these 2 lines together and then run again. I will get the 3 and 7, right? Yes?
What is the significance of the number you choose?
It doesn't matter. It doesn't matter. Any number. Just any number.
Just calling the
yes. Right. So usually we actually write the scripts, right? So it's for recording, right? So if we set up this line just for reproducibility, then we can just always make just the same number and same output if you set the seed. So this is for numbers, right? Then actually, what usually I use this sample function is for just some different purpose. For example, if you need to find some people who clean the rooms after whole courses, nobody want to do this. Just we need to just volunteer, but like nobody also want to volunteer. Then we need to randomly sample, take some people. So what we are doing is commonly, okay, so I'll make a group member factor. So let's say just member, and make a vector with Meena and Ting. And so I will put our TA's name here, Sarah. And let's say Olga. So among the 5 people, we need 2 people to clean the room today. Okay. Then I will run this. So now the member have a 5 name of our group member, and then I want to select the 2 among them. Then I will use a sample function, but instead of the 10, I will put here the vector for our name. So here, member, and I want to select 2 in these vectors. Then if I run here, now the CT again, I have to click this one. So in our stat departments, commonly we use this one for proctor 2. At the end of the semester, we need to some proctor for final exam. Sometimes it happens at 8 a.m. and Thursday, so nobody wants to do this, so we just use this stuff. So you can use this function anywhere you want, but this is one of the examples. So then, how we can use this sample function for our experiment. So let's remind our experiment design for IPRG data. So IPRG data, we have 4 conditions. Each one have 3 replicate. So total 12 MS run we need to run, right? However, we cannot make a MS run order like condition 1, 1, 1, condition 2, 2, 2, condition 3, 3, 3, condition 4, 4, 4. This is not good. We actually need to completely randomize this order, right? How we can do this? So we can use this order by this sample function. Okay. So then let's load our IPRG data that we used yesterday. So I will go back to our file, data folder, and then I will load our IPRG data, IPRG.RDA data. If I click it, it said yes. And then here, I can see here data IPRG is loaded. Okay, and now you should have a data IPRG data in environment. Everyone has IPRG? If not, please put the sticky note or just raise your hand and our TAs can help. If somebody have IPRG data, let's make a vector MS run. Let's make a vector MS run, which include the unique information of run column. Okay. During we are waiting for other people, try to remind what we did yesterday. Let's try to get the unique information of run column in data IPRG. So let's get the unique run information, run column information from IPRG data. If you succeed, let's put the blue note on it. So I hope everyone has an IPRG. So if we just try to remind, I will just double check what columns we have in IPRG. And IPRG have a protein and log intensity, run and condition, and so on. So I want to get some unique information from this run column. Then we can use the unique function, and then I want to get unique information of run column, but from where? From IPRG column. Okay. Then if I run here, now we have all unique information in MS vector. So let's check the MS vector, what it look like. Okay, they have a 12 MS run information, right? And then I want to decide the order for our injection order. Then how we can do it? How we can do it? In that case, we can use the sample function here. Just instead of the dismember, we use this MS information. However, not select 2 or 3, right? We want to select all 12. Means actually they are gonna select the 12 information among 12. Actually, generate the all random numbers. So here, I will just put the 12. Here, and you can see now this order is different. Or alternatively, what we can do, sometimes we don't know this number, or we make a more generalized, code. Then we can say here's length of MS. Okay. And then now we also have a different order here. So here 4C, 2B, but here 4A, 1B, and so on. Okay? So you can use this one. But this is a very simple, just a completely randomized order one. If you have a little bit more complex design, like the block design and so on, very few packages actually allow, but they have a lot of the restriction. So in that cases, you also need to use, a little bit complicate the code you have to make it for your experiment. Then let's go to our statistic part. So let's call our deployer. So we are gonna use some deployer or basic function. I will just doing the same thing with the two cases. If I use a deployer function, if I use just a generalized function, I will show you how we can make the same result. And then I will use our IPRG data. So now IPRG data, we have a quite big number of the protein information. For example, unique IPRG proteins. If you run it, you see like, and then actually we can double check how many unique protein ID we have. So in that case, I want to calculate the length of unique information of IPRG protein information. Then if you run it, it said there are 3,027 proteins, right? But let's start to focus on just one protein. So let's make another data, small subset data, one protein I will call from IPRG, and IPRG protein is, here's a picky part, SP, and this is the pipe, not L, this is a pipe, P44015, pipe, and VAC to east. And comma. Then if I run here, now I have here one protein data with the 12 observations. Okay?
How do you type that?
The pipe, I think this is if you succeed, please put the green note, the blue note. If not, please put the yellow one, and then the TA will help you. So we should have one protein data with the 12 observations. So that means from IPRG data, and then we have a square bracket, and then here's the comma, and I want to subset the data which have the protein ID is equal to this. If you want to practice another way, you can use another function for this subsetting, what we used yesterday for dplyr. This is advanced question if you already succeed. Yeah, there's another function we can self-filter, get the subset from dplyr functions. Or you can cheating on another, like some Blackboard. So this is, do you understand what is this line means? Yeah. Then you can do the same task with another function from dplyr. This is just extra question, but you can think about it, but just try to remind. So we can do the same thing with the filter functions. Filter function. Almost the same, but a little bit different syntax we have to use it. So I will call just temp data I want to make it. How I want to do, I want to filter of IPRG data. I want to filter the IPRG data. How protein information is equal to this. I will just copy this protein name. Okay. Then I will run. And then here you can see this one is also have 12 observations here, right? So these two lines actually doing the same thing, but just different syntax. So if I want to double check, it's really same. I will click this one protein data here, and then it will show here in view, and then you can see here all the protein name is so what we want, and then let's just try to memorize these numbers: 26.3, 20.61. If I click this TMP, that one is also same, only the one protein ID, and then this intensity is the same. Okay. So now everyone has one protein data, right? Now we are gonna start to calculate it. So there, let's introduce another function, aggregate, which means we are gonna aggregate the data by something, right? How we can do it? I will call subset of mean, and then I will use aggregate function. I want to aggregate log2 intensity information by condition from data is one protein, and how I can aggregate. The fun means function, not really fun, just function. Which function I want to calculate, aggregate by mean. Okay, so let's run this line, and then I will just want to double check what is this one has. It has condition and log intensity because we want to aggregate log intensity by condition. Yes. This one is tilt, means we want to like kind of the by. We want to aggregate log intensity by condition, or you can say we want to split the data by condition, and then aggregate by log intensity. Okay, so now we can get the this mean value. Yes. Oh, this is just you don't need to have a dot, like just my another naming one. I just want to separate it, so it doesn't matter you have a dot or no dot. Okay. Then, so small change. I want to calculate the standard deviation of log intensity by condition. What should I do?
Choose function.
Yes. Just small things. So instead of this mean, we can just change this standard deviation. So what I will gonna do, I will just copy whole things, and then just paste at the bottom. And then I want to just change this mean to standard deviation, but I want to make another data with standard deviation. If I didn't change it, actually we are gonna it's actually overwrite the data, so we are gonna lost our mean calculation. So I want to separate the data with the standard deviations. So if I run here, now solve that standard deviation. Now we can see also this is a standard deviation of the log intensity for each condition. Okay. So there are, if you want to more flexibility of this aggregation function, you can just question and aggregate will show all the flexibility of this function. So you can just double check here. Then I want to do the same thing with the deployer. Same thing, just same calculation, just want to same table, but with the deployer. So I will make just another one, self mean, but by deployer. How I can do this? So I want to calculate something from one protein data. So deployer case is most likely we need to say data first. So I will start with the one protein data. Then from one protein data, I will group by conditions, right? So from one protein data, okay, I separate this one protein data by conditions, right? And after we separate this one data, then what we're gonna do? I want to calculate the mean. So in this case, instead of the aggregation function, we can use summarize functions. So by condition, I want to summarize mean of log to intensity, right? However, we need to make the column name. We need to set the column name here. Okay. And if I run here, and let's check what we have. This is what we have. By each condition, we have a calculation of the mean, what we assigned here, and this is the mean of log to intensity. Okay? Okay. So then I will do short survey. Which way is easier for you? Okay? So deployer easier blue, aggregation function easier red. None of them. None of them. Which one is easier? Deployer red, and then aggregate function blue. Aggregate function blue, deployer red. Okay. This I can guess like it's almost half and half, right? Okay, let's see. Then same thing, I will give the short challenging. So I want to calculate the same thing, but I also want to calculate the standard deviation with the, okay, I will write it here. I want to calculate the standard deviation by deployer functions. This is short task 1. And I also want to calculate length of row by anything you're convenient. Okay, let's do 2 short challenges, and if succeed all of them, just put the sticky note, blue one, and then if you have a question or issues, just please put the pink one. Okay, I think it's for all naming is make people confused. Okay. So then let's try it together. So I want to calculate the standard deviation for each condition with the deployed functions. So this is really similar as what we did here, right? This is just we calculate the mean of the intensity by condition. But instead of the mean, we want to just calculate the standard deviation, right? So I will just copy this, completely copy this, and then paste. Okay, then what I will change is instead of here, mean, I will change this is a standard deviation. And then I will call this is the standard deviation. And then I will make another data, instead of 1, I will just call 2, right? And then click run, and let's check how it look like. Here it is. So here condition 1, and then here's our standard deviation. So I think the default of this default is always show the last 3 digits. So here it shows 1 to 4, and then here's the last 3 digit is 9 or 7. So that's why we need to just show the last 3 digits. 1. And then next one is I want to calculate the length of the row or number of the row for each conditions. How? I will just copy this one too. Instead of the standard deviation, what I can change is here just n or count, and then I will just change this one is count is n, and then I will just save this one to another data 3, then run, and then it has here we go. So each condition we have 3 rows, which means we have 3 log to intensity values. Okay. So now we can calculate the mean, and we can calculate the standard deviation. We can calculate the n and so on. The good thing is we already have some function, mean, standard deviation, and so on, but we don't have a standard error functions. If you want to calculate the standard error, if you already have a function for standard error, we can just easily change this is just SE or something else. But unfortunately, we don't have. So we actually need to manually calculate it. So how we can do this? So that's why I just posted here. So standard error calculation is by this. So we need to calculate the standard error first, a standard deviation first, and then square, and then divide by n, and then we need to make a square root. So we basically need to make this one by ourselves. How can I do? So here I will use the deployer functions. So ready? Let's calculate the standard error for each condition. Standard error of log 2 intensity for each condition. So let's start. Let's calculate with the deployer. So I start with the one protein data. Then I will group by conditions, right? This is so far the same as what we did before. Then I will summarize. So before we actually calculate the step one by one, but we calculate all together just within just one line. Let's do this. So I will calculate the mean is the mean of log 2 intensity. And not finished yet. I want to keep summarize something else. I want to calculate the standard deviation of log 2 intensity and comma, and I still want to calculate the length. So here, because we need these n numbers to calculate the error, so here n, right? And then I want all this calculation add to summary. Okay. Then summary has all this information while we calculate it separately. Okay, so now we have just one table with everything. Okay. So summary function is actually, if you have a big data table, we actually split by or just group by condition, and then for each condition, go to each row actually the summarize function make a new data how we can calculate by each group. That is a summarize function. We have another function, mutate. The mutate function is actually from here. We can mutate each column, like between here and here and here, whatever, and add another column. That is mutate. So this is two different. So it looks like the summary also doing some calculation, and then mutate also doing some calculation. But difference is summarize actually can make a new table because actually the number of rows should be changes. But mutate actually add another column from the original data. So that is the difference. So to calculate the mean, standard error, or something, we use the summary function, but the standard error actually we can calculate this from standard error and n, and we have to use the mutate functions. So from this summary function, let's make a standard error. So summary and I want to mutate of summary data, and then I want to add this standard error column. Okay, I will add standard error column should be let's write down this equation. So square root should be first. Okay, square root of square root of standard error square, right? Standard deviation square, right? Standard deviation and square, and then divide by length. Okay, so we can directly use the column, not column name of the summary. Then I just run, and then, okay, let's say previously we have a summary 4 different column, condition, mean, standard, and length. And let's see what is difference now. Now we have one additional column, so standard error. Okay? If you have this summary table, please put the blue note. If not, please put the red note. Yes?
So for your n, we just type n.
You can type the length.
Can you just type n and parentheses?
Yeah. Yeah, and then just empty. Empty, yeah. And next we are draw some plot with this calculation. So everyone need this summary tables. Okay, then let's start to make some plot for our statistics. Okay, so but first what we have to do, I want to use the ggplot. So let's load our ggplot to library ggplot to. Right? Then at this moment, I will use the summary data. I just want to make a mean and then just make some error bar, just different color and so on. Okay? So for first, we have to say what for ggplot first, we always make some frame first. What should be x-axis? What should be y-axis? And so on, right? So I will make a p colon ggplot, and x-axis should be group and a condition. So here, so x-axis should be these conditions, and then y-axis is by our mean, and then I will want a different color by different group. So color is conditions, and everything should be came from data summary. Data equal summary. Okay, so this is first frame for plot. From summary result, let's prepare the x-axis, let's prepare the y-axis, and then ready to be colored by group, the conditions. And based on this frame, I will put here add, and then I will add something, right? Plus, I will want to point. I will just make a point plot for this with this summary. So geom and point, and I will make a size equal 3. Okay, and here I run and nothing show up because I will make a plot and then put this plot in P. So P has a plot, but I didn't say show plot, right? So let's say, how is the P look like? Then just P, type it, and then just run. and then plot panel, you can see this, right? So x-axis is condition, y-axis mean, and then they put the point for each mean, and then different color, right? I will just play a little bit. So here, if I size equal, let's say 6, right? And then I just run this, like this big dot, right? The huge dot. So you can adjust as much as you want, okay? Then let's do something, let's make a little bit better. So let's make another plot, so P2. However, let's start with the P. Let's bring the P, and then I will add another layer and another layer, another layer, and then that will call P2, okay? So let's start P, and then I will add something. So this is our P. Oh, let's change this size is equals 3. The 6 is too big. So let's run this one again. Right? And here, if you see, there's no, we have a label for x-axis, we have a label for y, and then we have a legend here, but no title, and then your background is gray, and the whole line is white, and so on. So commonly, I don't like this. Personally, I don't like this gray one, so I just want to make a white background and then black line. Okay? Then let's do this. P plus, I will add another theme of the plot, just BW, black and white one. Okay? Then if I select this one and then run, now you can see like just whole color background is changes, right? So now we have a black line and then just white background. So here I use the theme and BW, but there are a huge number of the different type of the theme available. So we also don't know. So usually we just searching it, like how we can change this or something. They show some template and then we can choose this one. And then after that, I will add label differently. So in that case, I just put the plus sign here, and labs means labels, and then what kind of labels is I want to put the title. And name will be just mean here. And then I want to change the x-axis label too. So x equal here now condition, but I just want to change this group, right? And I also want to change the y-axis label too, now mean, but I want to change this is just log to intensity. So y equal should be log to intensity. Okay. Then I will just select this and I run it, and then now you can see we have the title, and then label for x-axis, y-axis are changes. Okay. Okay. Then I will make more nicer. So in the visualization section, like for program 6, they probably Lauren talk about another one too. But here's just a basic ggplot2 functionality. Then what I want to do is I want to change something else. So here I just add the plus sign here, and then I want to change another things. So usually theme function have quite a lot of the different options. So first what I want to do is actually I don't like the legend at the right side. I want to put the legend at the bottom, not right. So here what I can do in the theme function, I will say legend position should be at the bottom, right? So instead of the right, I will put this one at the bottom one. And I also want to do legend, the background color should be rectangular. With color equal black. And the legend key equal element rectangular, and then color equal white. So I will run this, and then let's see how P2 look like. So now we actually adjust our legend. So this one actually come down here, and then I actually make a box for this one. Okay. So there are so many functionality for here. So it's really up to you as much as you want. So you can do anything you want. So let's fix this. Is just our basic plot, and then next step is I want to add error bar here. Error bar here. So let's just start with the P2. Let's just start with the P2, and then I want to here, and then I want to add error bar here. So P2 and plus, and then we used geom error bar function. So to use this error bar function, we have to tell from where to where. Like where's the top and where should be the bottom value. So let's start with the AES. And then we need to say what is the maximum value of y-axis, what is the minimum value of the x-axis, right? So now, okay, if we have our mean value, and then if you want to add like this error bar here, we have an error bar mean value here, and then actually this is okay. Let's say we want to the error bar with the standard deviation. So this value is a standard deviation, and then this value is a standard deviation, right? So maximum value should be mean, this mean value plus standard deviation value, right? And then this minimum value should be mean plus and minus standard deviation value, right? So we just assign this value over here. So y-axis maximum value equal mean plus SD, and y minimum value is mean minus SD. Okay. Then I want to change the title. Now here over there is a mean, but I will change this one is mean with the standard deviations. And then I run, and then you see there are some bar, some bar there, right? But you can see this width of the, the top and bottom is too wide, right? So I want to fix this one as a little bit low, narrow. So at the here, I can put width equal 0.1. Now you can see it's much narrow, the bar we can draw it. Okay so far? If somebody succeeds so far, I will give you a small task. Then let's draw the point bar. Let's draw this same plot with standard error bar. So now this is the error with the standard deviation. But if you want to change this error bar with the standard error, why you have to change it? Then answer. Okay, so let's try to do this. So I saved our plot with the standard error P3, and then I want to change a little bit, and then save this one with the standard error in the P4. So I just completely copy this one. Then what I can change is I just change the error bar. So with the standard error, I think we can just auto adjust this value, right? Instead of the PD, the SD, we can just calculate it with the standard error, and then it will make a standard error bar. Then here we can change this one is SE, and here's SE, and then I will just change this is E, and then save this in the P4 and run. Right, and then let's look at this panel. So let's make this visible. So P3 is with the mean with the standard deviation, and then P4 I will run it. P4 is with the standard error, right? So I will just go back again. P3, and then here's the P4. Let's focus on, here is hard to see how much is difference. Okay, let's make this is bigger. So any the standard with the standard deviation, we can see this is the bar is out of the point, and then let's try to remember like this, friends. And then how it look like for P4. now I can see this error bar is narrow than with the standard deviation, right? And this also become a narrow. It is because it makes sense for this calculation. Actually, we divide by n, and then square root. Actually, standard error should be narrower than the standard deviations. Okay. Then last one. Let's try to make an error bar with the confidence intervals. Confidence intervals. So let's go back to our summary, how it look like. So our summary data has our summary data has mean, standard deviation, and standard error and length. For confidence interval, we actually need to calculate another this bar, like what is our confidence interval, right? So confidence interval, we can calculate standard error times t distribution is 1 minus alpha 0.2 and 0 freedom. That is kind of our error bar. We have to, it should be. So we can just calculate again with the multiplier. So if you remember how we can calculate the standard error, I will just copy this part. And then instead of standard error, I will make two things. I will make where should be the lower limit, and then where should be the upper limit. So upper limit, let's say just upper, and then this equation should be and lower is exactly same, but it should be minus. So here should be this one mean plus, and then this one should be mean minus, so this one actually directly calculated this upper limit and then lower limit. So from mean, and then what this length should be, this length should be this one. And then QT means T distribution. Based from the T distribution, we actually calculated this part. And then we use the standard error, what we have before. Okay. Then let's check the summary data. Now summary data has, now we can see 4 times 7 column. It shows only 5 column here, but 2 more variable with the upper and lower. So this upper is this value, and the lower is this value. Okay. Then with this value, we can draw this plot with the confidence interval error bar. Okay, so I will just copy this one. exactly same here, but here maximum I just replace with upper value, and the minimum it should be lower value, and then I will make this one is P5, and then this one would be 95% confident intervals. And then if I run, okay, so in that case, so I got an error message because originally I changed the summary value. But here P2 actually used the summary without our last calculation. So in that case, we actually go back to our P2 again, or I can just type it here again. For ggplot2 ASE now we can draw the same plot with the confident interval error bar, and then you can see now this error bar is much wider than before. Okay. So I think we can stop here for morning refreshment. But let me know our workaround, and if you have an issue, or if you have another question, how you modify plot or calculate something else, please let me know.